Alright, friends, a SpongeBob review how-to. So, the first activity asks you that for each genotype indicate whether it is heterozygous or homozygous. So we know hetero means different. So this big B and little b are different, so that would be a heterozygous, labeled HE. And this HO, homozygous, means same. So these two F's are the same. So you're going to go through and label each section, or each line with homozygous or heterozygous. Remember using HE and HO. Now it asks which of the genotypes in number 1 would be considered purebred. Well, we know purebred is homozygous, meaning same. So you would list 2 or 3 of the homozygous pairs from this question number 1. And you would do the same for this sub-question, hybrids. Well, if purebloods mean homozygous, then hybrids, meaning 2 of different, would be heterozygous. So you would list some of the heterozygous pairs down here. Number 2 tells you to determine the phenotype for each genotype. Well, I've given a capital Y, and I'm told that yellow is dominant to blue. Well, if there is a capital Y, I know it's dominant, and dominant will always show up. So this capital Y has to be yellow. Now there's a capital here. There's a capital here. So if a dominant always shows up, what color would this be? We have little y, which is homozygous recessive. If yellow is dominant to blue, blue is recessive. So this would be blue. Now, you're doing the exact same thing for square shape is dominant to round. Exact same thing for square shape is dominant to round. Now, number 3. For each phenotype, give the genotype that are possible. So if a tall head is dominant to a short head, Patrick clearly has a tall head. So he can either have a tall head is capital, so we can either have a big T, where did I go? Big T, or it says all possible combinations that are possible, so we can do big T, little t as well. Short, we know, can only be little t. If pink is dominant to yellow, do the exact same thing. Create the genotypes. You did this for your project already. Alright, that is 1 through 3. Number 4. SpongeBob SquarePants recently met Susie Roundpants at a dance. SpongeBob is heterozygous. Immediately, I know I'm going to have, let's go ahead and say he's a pants. But I like B's because you can tell the difference. SpongeBob is heterozygous, so I'm immediately going to go ahead and put him on the side. For SquarePants. Well, a heterozygous always shows dominant, so that means square has to be dominant. Susie is round, so she has to be recessive. And I can't draw on the side here, so I'm just going to go here. Alright, now it says create a Punnett square to show the possibilities. Well, we know that top goes down, so I'm going to bring this B I just wrote over here down here. 1, 2. This little b, 1, 2. I'm going to come over here to this b, 1, 2. This b, 1, 2. Now it says list all the possible genotypes and phenotypes for their children. Well, genotypes we know are letters, genotype, letters. So I see that I have a big B, little b, and I have a little b. Well, I know now phenotypes is physical. So a capital is dominant, so I know that's going to be square. And lowercase is recessive, so I know that's going to be round. Now it asks, what are the chances of a child with a square shape? Well, A square shape requires a capital letter. There are 2 boxes with a capital letter. 2 out of 4 is 2. 2 out of 4 is 50%. Remember, the entire box is worth 100. Each square is worth 25. Well, I don't even have to look at the chart. If it's 2 out of 4, the other half has to go somewhere. So it's 2 out of 4, 50%. And I am done with number 4. Now, number 5 is the same. We have both are heterozygous. So you're using capital and a lowercase, and their body is pink. So pink is dominant over yellow. All right, do the exact same thing. Number 6, everyone in Squidward's family has light blue skin, which is dominant. So we know light blue is dominant. His family brags that they are purebred. He recently married a nice girl who has light green skin, which is recessive. So we know Squidward it says purebred, so he has to be homozygous. So Squidward has to be homozygous dominant. And the girl he married has to be homozygous recessive. So we have to do a homozygous dominant with a homozygous recessive. And we are familiar with that terminology, or that Punnett square, because that was one of our warm-ups. We know that's going to equal 100% of something. And now it asks, would you consider that a purebred? So look at the created genotype and decide, is that a homozygous? Are they purebred? All right, number 7, assume one of Squidward's son who is heterozygous for light blue also marries heterozygous. So now we have heterozygous. Another Punnett square. Number 8. Mr. Crab and his wife recently had little Krabby, but he has not been a happy occasion for them. Mr. Crab has been upset since she first saw her new baby, who had short eyeballs. She claims that the hospital goofed and mixed up her baby with somebody else's baby. Mr. Crab is homozygous for tall eyeballs, so we know tall is dominant, while his wife is heterozygous, and she also has tall. So we should have capital and capital lowercase. Now, some members of her family have short eyes, which is a recessive, so we know that because she's heterozygous. So create a Punnett square for capital, and capital lowercase. Once that Punnett square is completed, list your possible genotypes and phenotypes. Now explain, is it possible for Mr. Crab and his wife to have had a child who has short eyeballs? Is it possible for them to have a child with a recessive trait, is what's being asked there. Explain why or why not. And that is it. That is 8.5 minutes. If you went along with us, this shouldn't take you more than 15. Thank you so much.